Welcome students once again to my YouTube channel whose name is Knowledge Entertainment. So in the previous video we have solved some questions on trigonometry and we will keep it continue in maybe 3 or 4 more videos because there are so many important questions from the point of view of CBSE, from the point of view of IACSE and from the point of view of IIT and other entrance examinations. So I'm starting with the first question, that is the question is evaluate sine 18 degree. So this is the solution, how to find the value of sine 18 degree. So we'll start the solution. Let x be the 18 degree. Then multiplying both sides by 5, you will get 5x is equal to 90 degree. You can break this 5x into 3x plus 2x is equal to 90 degree, and then take this 2x to the other side, that means right hand side. You will get 3x is equal to 90 degree minus 2x. Now take cos on sine on both sides. So take sine on both sides, sine of 3x, and here you will get, take cos on both sides, not sine. Cos of 3x is cos of 90 minus 2x. Now cos of 3x, we know the formula is 4 cos cube x minus 3 cos x. On the other hand, cos 90 minus theta, we know that cos 90 minus theta is sin theta. So this cos 90 minus 2x will become sin 2x. Take out one cos x common from here. Cos x is common and you will left with 4 cos square x minus 3 is equal to, on the other side you will have the formula for sin 2x, that means 2 sin x cos x. Since cos x is not 0, so you can cancel out cos x from both sides, and cancelling cos x from both sides, take the term 2 sin x from the right hand side to the left hand side. You will get this 4 cos square x, I am writing 4 into 1 minus sin square x, this is minus 3, and this term to the left hand side will become minus 2 sin x is equal to 0. So this equation can further be simplified into 4 sin square x. I am actually multiplying both sides by minus 1 in the step, so that this minus 4 sin square x will become 4 sin square x, and this minus 2 sin x will become plus 2 sin x, and the constant term, this is 4 minus 3. 4 minus 3 is 1, but since we are multiplying by minus 1, it will become minus 1 is equal to 0, and this is a quadratic equation in sin x now. So the value of sin x will be minus 2 plus minus under the root 4 minus 4 times AC. So 4 into minus 1 is, you will get plus 16 divided by 8. So it is minus 2 plus minus, this is under root 20. Under root 20 you can write 2 under root 5 divided by 8. Since x is equal to 18 degree is in the first quadrant, and we know that in the first quadrant the value of sine is positive, so both negative signs will not work. So you will have to take here plus sign so that the quantity will become positive. So ignoring the minus sign and taking out 2 common and cancelling, we will get the value of sin x, that means sin 18 degree is equal to root 5 minus 1 over 4. This is the value of sin 18 degree. Now from this value of sin 18 degree, we can solve another question of the similar type, and the question is to evaluate the value of cos 36 degree. So I am writing the next question as evaluate cos 36 degree. That is a very easy question, very simple. That cos 36 degree, you can write cos 2 times 18 degree. That is cos 2 theta. And we know that cos 2 theta has several formula. One of them is cos square theta minus sin square theta. The other one is 2 cos square theta minus 1. Another one is 1 minus 2 sin square theta, and that is what we are to apply here, because we know the value of sine 18 degree. So we will apply the third formula, that is 1 minus 2 sin square 18 degree. So that is the value of cos 36 degree. And now it's very simple. You have just to substitute the value of sine 18 degree here, square, simplify, and you will get the value of cos 36 degree. I am not going to solve this because it is just a calculation work now. So we move on to some more questions. Another important question is prove that tan 3a minus tan 2a minus tan a is equal to tan 3a, tan 2a, tan a. This we are to prove, and this is another very important question. So how to solve it? The solution is not difficult once again. So tan 3a, you can write this 3a as 2a plus a. It's very simple. And now on the right hand side apply the formula for tan a plus b, that means tan x plus y. And you know that tan of x plus y is tan x plus tan y divided by 1 minus tan x tan y, and that is what I am going to apply on the right hand side. This tan 3a will remain as it is, and on the right hand side I am applying the formula, so it is tan 2a plus tan a upon 1 minus tan 2a tan a. Now this term in the denominator, this will be get multiplied into the left hand side, and tan 3a multiplied by 1 will be tan 3a, and tan 3a multiplied by tan 2a tan a will be tan 3a tan 2a tan a. So this term is going to be multiplied on the left hand side. So what I'll get tan 3a, the product of these two, then this minus sign, and product of these two is tan 3a tan 2a tan a is equal to the numerator, that means tan 2a plus tan a. Now it is only remaining to transfer the terms from left hand side to right hand side, and from right hand side to left hand side. Take this term to right hand side and these two terms to left hand side, and the required result, that means tan 3a, this one, and these two will be minus here, minus tan 2a minus tan a is equal to, this minus term will go on to the right hand side and will become tan 3a tan 2a tan a, which is our required result. So this was another question which was important from the point of view of examinations, and we'll solve more and more questions. As I said, it may be in next 2 or 3 more videos we will be solving these type of questions. Next question I'm taking, prove that secant 8 theta minus 1 over secant 4 theta minus 1 is equal to, this we have to show that tan 8 theta upon tan 2 theta. This is the right hand side where we have to arrive. So we will start this from the left hand side. The solution to this question will start from left hand side, and left hand side is secant 8 theta minus 1 over secant 4 theta minus 1. Write 1 upon cos 8 theta here, 1 upon cos 4 theta here. Take LCM and simplify. What you will get from the denominator, LCM will be cos 4 theta, and then will go into the numerator. So in the numerator you will get cos 4 theta from the denominator of the denominator, into, from the numerator the LCM will be cos 8 theta, and that will go into the denominator, cos 8 theta. Whatever the left terms will be, from the numerator it will be 1 minus cos 8 theta, and from the denominator it will be 1 minus cos 4 theta. So this is just what I have written, 1 upon cos for these two secants and then simplification. Now what to do, that this 1 minus cos 8 theta, cos 4 theta, and this 1 minus cos 8 theta, we know that 1 minus cos 2 theta is equal to 2 sin square theta. So this 1 minus cos 8 theta will become 2 sin square 4 theta. 2 sin square 4 theta, and this is cos 8 theta. This we will keep it with us. And this 1 minus cos 4 theta, again I am going to write it as 2 sin square 2 theta. 2 sin square 2 theta. So is equal to, what we have to do now, this sin square 4 theta, we will separate the two sin 4 thetas because they are multiplying. So 1 sin 4 theta I am taking with this 2 cos 4 theta. So 2 cos 4 theta sin 4 theta will become sin 8 theta. So it will become sin 8 theta, because we know the formula that 2 sin A cos A is equal to sin 2A. So 2 cos 4 theta sin 4 theta, and 1 sin 4 theta is left. So that sin 4 theta I am going to write it here. In the denominator it is cos 8 theta, cos 8 theta, and 2 sin square 2 theta. What we are to do in the next term, this sin 8 theta over cos 8 theta, this will become tan 8 theta. This sin 4 theta I am going to write it as 2 sin 2 theta cos theta. So 2 sin 2 theta cos 2 theta, and divided by 2 sin square 2 theta. This 2 will be cancelled out. One of these 2 sin square thetas will be cancelled with this sin 2 theta, and you will left with tan 8 theta divided by, this is sin 2 theta, and take this sin 2 theta to the denominator of the denominator. So sin 2 theta over cos 2 theta. Sin 2 theta over cos 2 theta will become tan 2 theta in the denominator. So tan 2 theta, and this is the required right hand side what we wanted to prove. So it is the solution of this question. So I will take some more questions. It is very important to learn the technique how to solve these questions, and this is possible only with due practice. So this practice is a must to solve more and more questions on this. So another question I am taking here, if alpha and beta are roots of, if alpha, beta are roots of the equation, roots of the equation a tan theta plus b secant theta is equal to c, then show that tan alpha plus beta is equal to 2ac upon a square minus c square. This is our question. This is what we are given and what we are to prove. Solution is not very difficult, but in fact it is very easy. Just what you have to keep, the concentration on what is required, what the result you need. So this equation, this is a tan theta. I am taking this c to the left hand side minus c, and this b secant theta to the right hand side minus b secant theta. And now square both sides. Square both sides. Here you will get a square tan square theta plus c square minus 2ac tan theta is equal to b square, and you will get secant square theta. But the value of secant square theta, we know that in terms of tan it is 1 plus tan square theta. Now this equation is completely in only one trigonometric function, and that is tan theta. That means if the roots of the equation are alpha and beta, in terms of tan we can talk that the roots of these equations are tan alpha and tan beta. Now I am collecting the terms. First of all, this is a square tan square theta, and this is b square tan square theta will become minus sign. When I'll take this to the left hand side, you will get a square minus b square tan square theta. Then this minus 2ac tan theta, minus 2ac tan theta, and this plus c square minus b square, plus c square minus b square is equal to 0. Clearly, this is a quadratic equation now in tan theta. So the roots will be tan alpha and tan beta, because the roots of theta are alpha and beta, and the quadratic equations is in tan theta. So the roots will be tan alpha and tan beta. So what will be the sum of the roots? Sum of the roots, that means tan alpha plus tan beta will be, we know that if a quadratic equation is there, ax square plus bx plus c is equal to 0, then the sum of the roots is equal to minus b upon a, that means minus coefficient of x divided by coefficient of x square. So here it will become minus coefficient of tan theta is minus 2ac divided by coefficient of tan square theta, that means a square minus b square. And this is the sum of the roots. And what will be the product of the roots? Product of the roots, that means tan alpha into tan beta. Product of the roots is c upon a, that means the constant term divided by the coefficient of x square. Here the constant term is c square minus b square divided by the coefficient of tan square theta, that is a square minus b square. So we are having values of tan alpha plus tan beta and tan alpha tan beta. But what we are to get? We are to get tan alpha plus beta. And we know that tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta. And you are now having values of tan alpha plus tan beta as well as the value of tan alpha tan beta. So just you need to substitute the values and simplify. Tan alpha plus tan beta is, this minus and minus sign will be cancelled. You will be left with 2ac upon a square minus b square, and 1 minus tan alpha tan beta is there, c square minus b square upon a square minus b square. From the denominator terms, take a square minus b square LCM. When you will take a square minus b square LCM, a square minus b square from the numerator and the denominator will be cancelled out. What you will be left with? You will be left with 2ac in the numerator, and in the denominator you will get a square minus b square minus c square plus b square. So b square will be cancelled out, and you will get 2ac upon a square minus c square, which is the required result to be obtained. So this is the question. If alpha beta are the roots of a given equation, a tan theta plus b secant theta is equal to c, then the value of tan alpha plus beta is 2ac upon a square minus c square. So we'll move on to the next question. Another question of this type, you can say important from the point of view of examination. Actually, I am taking only those questions which are really important. So the next question is, prove that 2 sine square beta plus 4 cos alpha plus beta, 4 cos alpha plus beta into sin alpha sin beta, sin alpha sin beta plus cos 2 alpha plus beta, cos 2 alpha plus beta is equal to cos 2 alpha, cos 2 alpha. Since I am having not enough space, so I am taking this as the left hand side, and I am going to start the proof from here. So this is your left hand side. Ignore this for some time. That will be the final result we will arrive at. So we are to start from here. This is your 2 sine square beta, 2 sine square beta. This is your 4, and this cos alpha plus beta, I am writing cos alpha, cos beta minus sin alpha, sin beta multiplied by this sin alpha sin beta plus this I am writing cos 2 alpha plus 2 beta. Open this bracket and apply the formula for cos x plus y here. So in the next step you will get 2 sin square beta plus, open the bracket, this is 4 cos alpha cos beta sin alpha sin beta minus 4 sin square alpha sin square beta and plus, now I am going to apply the formula for cos x plus y here, cos 2 alpha cos 2 beta minus sin 2 alpha sin 2 beta. Look at this term. Look at this term. This 4 I am going to write it as 2 into 2. So this is 2 cos alpha sin alpha. 2 cos alpha sin alpha is sin 2 alpha and 2 cos beta sin beta. 2 cos beta sin beta is sin 2 beta. So this term will become sin 2 alpha sin 2 beta with positive sign, and here you are having minus sin 2 alpha sin 2 beta. So this term will be completely cancelled. So what you will left with now, 2 sin square beta minus 4 sin square alpha sin square beta plus this term. Once again I am applying the formula for cos 2 alpha as well as for cos 2 beta. So cos 2 alpha is 1 minus 2 sin square alpha and cos 2 beta is 1 minus 2 sin square beta. Once again open the last bracket. So 2 sin square beta minus 4 sin square alpha sin square beta, and now I am going to open the bracket. 1 multiplied by 1 is 1. 1 minus 2 sin square beta is minus 2 sin square beta. Minus 2 sin square alpha into 1 is minus 2 sin square alpha. And minus 2 sin square alpha multiplied by minus 2 sin square beta is 4 sin square alpha sin square beta. And once again this term will be cancelled and 2 sin square beta will also be cancelled. You will left with only two terms, 1 minus 2 sin square alpha, which is well known formula for cos 2 alpha. That means you are required right hand side. So this is how to get rid of several terms to get simple combination or simple term containing one or two terms. So we'll solve more question today. As I told you earlier while starting this video that we will solve several questions of trigonometry in this video as well as in coming 2 or 3 videos. So one more question I am going to take here. If sin alpha and cos alpha are roots of, if sin alpha, cos alpha are roots of the equation, ax square minus bx plus c is equal to 0, then show that a square minus b square plus 2ac is equal to 0. This is what the result we want to obtain. Solution. Once again, what we are given, we have to concentrate on that. Sin alpha and cos alpha are the roots of this equation. And we know that the sum of the roots minus b upon a, the product of the roots c upon a, because it is a quadratic equation. So sum of the roots, sum of these two roots, sin alpha and cos alpha, that means sin alpha plus cos alpha, sum of the roots is minus b upon a, but here one minus is already there, so it will become b upon a. And the product of the roots, sin alpha into cos alpha, will be c upon a. So let it be equation number 1 and equation number 2. Squaring 1 both sides, squaring 1 both sides, what we are to get? We will get sin square alpha plus cos square alpha plus 2 sin alpha cos alpha is equal to b square upon a square. Now this sin square alpha plus cos square alpha is 1 plus 2 this sin alpha cos alpha. From the equation number 2 it has value c upon a. So 2c upon a is equal to b square upon a square. Now just you are to multiply both sides by a square and then collect terms on the left hand side. Keep right hand side equal to 0 and you will get the required result. I am not going to prove these two steps because they are very easy. So I am going to move on to the next question. Next question is based on the values of angles of trigonometric functions. So question is evaluate sine 20 degree, sine 40 degree, sine 60 degree, sine 80 degree. We are to evaluate this term, this value. So we have to start with this term sine 20 degree, sine 40 degree, sine 60 degree, sine 80 degree is equal to the value of sine 60 degree is known to us. The value is root 3 by 2. So first of all substitute the value, that is root 3 by 2. Then this is your sine 20 degree. This sine 40 degree I am going to write it as sine 60 degree minus 20 degree. Then this sine 80 degree I am going to write it as sine 60 degree plus 20 degree. Then there is a formula. The formula is sine a plus b, sine a minus b is sine square a minus sine square b. This formula I will apply this place. This is sine a minus b, sine a plus b, and it will be converted into sine square a minus sine square b. Rest of the terms will remain same. Root 3 by 2, sine 20 degree, and as I have told, the formula will be applied. It will become sine square 60 degree minus sine square 20 degree. So it is root 3 by 2 sine 20 degree and sine square 60 degree. Once again we know the value of sine 60 degree. The value of sine 60 degree is once again root 3 by 2 and the square will become 3 by 4 minus sine square 20 degree. Take 1 by 4 outside from here and multiply. So 4 coming from the denominator multiplying here will become root 3 by 8. Here we will get sine 20 degree and in the bracket you will be left with 3 minus 4 sine square 20 degree. So it is root 3 by 8 and multiply this sine 20 degree in the bracket. So what you have to get? 3 sine 20 degree minus 4 sine cube 20 degree. And if you remember, this is the formula 3 sine theta minus 4 sine cube theta. This is the formula for sine 3 theta. Theta here is 20, so sine 3 times 20 degree. 3 into 20 is 60 degree, so this will become sine 60 degree. Root 3 upon 8 and it will become sine 60 degree. And once again, the value of sine 60 degree is root 3 by 2 and multiplying them together you will get 3 upon 16, which is the final value of this given term. So I am stopping the value here. I would like to thank you before leaving you here for liking my videos, for sharing it with your friends, especially with 10+1 students, and thanking you for subscribing my channel. Thank you. Thank you once again. In the next video, we will meet again with several questions on trigonometry. Thank you.